So starting on problem 3, question B, so this is 3b. I am solving for x in all of these, and remember, you only have to check for extraneous solutions if you have ln or log. So in this case, I'm just going to minus 8, 7 equals 5. I'm going to multiply by 3 on both sides to get rid of the 1/3. And then this is base 4, so I need to do log base 4 on both sides. So that's going to give me x minus 7 equals log base 4 of 15. And on the test, you're not going to have a calculator, and you're not going to be able to just evaluate log base 4 of 15, so just leave it like that. So your final answer here would be x equals log base 4 of 15 plus 7. This one, pretty simple. I need to get the 9 away to free the x, so I can do log base 9 on both sides. So x equals log base 9 of 5. So then on D, this is a little bit different. This is using exponent rules, so I'm going to write that. You're going to use your exponent rules to get the... I'm going to use my exponent rules to get the same base. And you always think of going down. Go down. So I'm going to go from 25 to 5 squared. I'm going to write that in parentheses. And then 1/5 is going to switch to 5 to the negative 1 equals negative x plus 6. And remember, with exponent rules, if I have parentheses, I can multiply. So I'm going to distribute these out here. So that gives me 5 to the 8x equals 5 to the... That gives me a positive x and a minus 6. So now that they have the same base, I can do log 5 on both sides. Subtract x. And that gives me x equals negative 6/7. Similar problem here. So I've got this. I'm going to go, this 49, I'm going to take to base 7 because this is already base 7 on the other side. So I'm going to leave the other side untouched. 7 to the 2x equals 7 squared. That's how I can rewrite 49. 2x minus 7. Distribute the 2 out. So I've got 7 to the 2x equals 7. 2 times 2x is 4x. 2 times 7 is 14. Then I will do log base 7 on both sides to get the base 7 away. So 2x equals 4x minus 14 minus 4x minus 4x. Negative 2x equals negative 14. Divide by negative 2 on both sides, and that gives me x equals 7. Starting on 4a, this is... These are the problems where you're really going to have to check for these extraneous solutions. You're really going to have to check for these extraneous solutions. And there is a small typo on mine. This should be a minus on yours, I think. Yep, it should be a minus on yours. But ignore that. Actually, let me make sure I change that on the study guide here, because for this to work out, this should have been a minus the way I wanted it to. Minus. So remember, I've got to combine to the same base. So I've got to combine to the same base. So I'm going to have ln subtraction is going to become division. So I've got 3x plus 61 over x minus 7 equals ln of x plus 8. And then here, the way this is going to work, I'm going to do base e on both sides, so my ln's go away. I'm left with negative 3x plus 61 over x minus 7 equals x plus 8. To get this out of the denominator, I'm going to multiply by x minus 7. And that's going to give me negative 3x plus 61 equals x squared plus x. So I'm multiplying these right here. X squared plus x, sorry, my brain's lagging, plus 50 minus 56. And then remember, with a quadratic, you always need a side to equal 0. So with the quadratic, you always need to get it equal to 0 to solve and by factoring. So I'm going to get this side away. Minus 61, so minus 61. Minus 117. And 117, you're thinking what adds to the middle and multiplies to the end. That is 9 and 13. So 0 equals x plus 9. Oh, no, sorry, x plus 13, because it's a positive. And x minus 9. So the solutions I have to try are x equals negative 13, parentheses are liars, and 9. And remember, you've got to go through and plug these into every argument until it fails, or it has to pass all of them. So the first one, I'm going to plug in negative 13, so negative 3 times negative 13 plus 61 is going to give me 39 plus 61 should be 100. Or wait, what? Yep. Let me make sure my math's right. 3 times 13 plus 61. Yep, 100, because the negatives cancel out. That's good so far. I've got negative 13 minus 7. That's negative 20. So because of that, negative 13 fails. So now I've got to check 9. Negative 3 times 9 plus 61. That is 34. And you can do it step by step. I'm just doing it for time's sake in my calculator. So then I've got 9 minus 7 to check it there. That's 2, that's positive. Okay, and then I've got to check it here. 9 plus 8, that's 17. Oh yeah, boom, good. So 9 works. Okay. This one, I've got addition becomes multiplication, log. I'm going to multiply these together. X, log of x squared plus 10x plus 21 equals log base 10 of x plus 1. And then I can do, this is log base 10, right? Because it's not written there, so I can do base 10. I have x squared plus 10x plus 21 equals x plus 1. Subtract these over to get a side equal to 0. Which is going to factor to x plus 4, x plus 5 equals 0. So x equals negative 4 and negative 5 is what I've got to check. Remember, got to check it in all of my arguments here. So let's check it in the first one. So negative 4 plus 3 is negative 1. Negative 4 doesn't work. Okay, well, let's try negative 5. So that would be negative 5 plus 3. That's negative 2. So negative 5 doesn't work as well. So in this case, if both of them don't work, there is no in a solution. And a quick note on A, remember, if just one of them works, you'll often see it as just the one that works only. So x equals 9 only. Okay, see? You combine subtraction with division, so log of 3x minus 7 over x minus 5 equals log of 2. I'm going to do 10 as the base on both sides. So 3x minus 7 over x minus 5 equals 2. Multiply that over on both sides. 3x minus 7 equals 2x minus 10. And then if you do the math here, I'm not going to show my steps. Just for time's sake, it should give you x equals negative 3. Okay, and then on D, you've got two logs equal to each other already, so there's not really anything to combine. All I've got to do is base 12 on both sides. 3x plus 5 equals 13x minus 7 minus 13x minus 13x minus 5. That gives me negative 10x equals negative 12. Divided by negative 10, divided by negative 10, that gives me x equals 6/5. On 5, I've got write the expression log base what of okay in log base nice form. This is the change of base. So remember, for change of base, you always, whatever form you're rewriting it in, okay, it's always going to go on top and bottom. So log base nice over log base nice. The way that I remember what goes where is base on bottom. So the base of my original expression, which is what, becomes the argument on bottom, and the original argument stays the argument. Now for 6, it wants to expand the expressions fully. Oh, and I just realized, crap. I need to go in here and check my answers on D. So if you were watching and say, Mr. Hampton, you forgot to do something, I sure did. So I need to do 3 times 6/5 plus 5. Sorry, I'm doing this near the end of the day. That's going to give me 18 over 5. So it's 18 over 5. And I'm going to change the 5 to 25 over 5. Which is 43 over 5. Yep. So 43 over 5, that's positive, that's good. I'm going to erase some of this here. Just to make room. And then I've got to plug it in here as well. I've got 13 times 6 over 5 minus 7, which is going to be 78 over 5 minus 7 so I need to change the 7 to the 5th. That's going to be 35 over 5, which is going to be 43 over 5. So weirdly enough, they both give you 43 over 5. So which makes sense because it's two logs set equal to each other. So they both give me 43 over 5. Both of them are positive, so this works. Sorry about that small error. Like I said, I'm doing these during my planning, which is near the end of the day, and my brain is a little tired. So expand the following expression fully. So I'm going to break these up. So remember, the top breaks into addition, the bottom into subtraction. So it's going to break up into ln of 9 plus ln of e to the 7th minus ln. And I'm going to go ahead and write square root of r as r to the 1/2. So square root is the same thing as the 1/2. So ln of r to the 1/2. So if I'm expanding, remember this goes in front. So ln of 9 plus 7 ln of e minus 1/2 ln of r. And remember, ln of e here simplifies to 1, so for all intents and purposes it cancels out, so it's ln of 9 plus 7 minus 1/2 ln of r. Same thing here. So I'm going to break this apart, the top into addition. Move it to the front, move it to the front. Log base 9 of 11 plus 4 log 9x. Oh, not 5. That's a 3, right? Yep. 3 log a 9 of a. So when you're expanding, all you're doing is break apart the fraction first, then if there's exponents, move the exponents to the front. 7, we've got condensed the following expressions fully. So we're going to go in reverse order this time. So the first thing I'm going to do is move the exponents to the top. So I've got log base 11, and then 27 to the 1/3 is what I'm going to end up with here. That's the same thing as the cube root. So 1/3 is the same thing as cube root of 27. Cube root of 27 is what number times itself 3 times is 27, which is 3. Because 3 times 3 times 3 is 27. So I can rewrite that as log base 3 minus log base 11d to the 5th plus log base 11 of y to the 13th. And remember, when I combine these, addition goes on top and subtraction goes on bottom, because subtraction becomes division, addition becomes multiplication. So I'm going to multiply these two underlined here for the top, so log base 11, because this is positive here and this is positive here. So I've got log base 11 of 3y to the 13th over, then this is negative, so I'm going to put d to the 5th on the bottom. Same thing here, to the exponents, 7, oh, going too fast, ln a to the 17 plus ln b to the 34 minus ln of c. So then addition, because multiplication goes on top, so ln of a to the 17th times b to the 34th over c. So now this one's a little bit different, but the rules stay the same. So the exponent moves to the top, but notice it's going to be over the whole thing. So it's going to be ln of x plus 3 all to the 1/2 minus ln of x to the 7th minus ln of 8. And remember, this looks really confusing maybe, x plus 3 to the 1/2, but if you remember, this is the same thing as the square root, so I can rewrite this as ln square root of x plus 3 minus ln x to the 7th minus ln of 8, and subtraction goes to the bottom, multiplication goes on top when I'm combining these, so I'm going to have ln of square root of x plus 3 over 8, and x to the 7th go on bottom, so I'm going to write that as 8x to the 7th multiplied together. And then for this one, this is super easy. Just move that to the top. I've got log 8 a to the 12th plus log 8b, and this is multiplication because it is addition, So log 8, a to the 12th, b.